I did negative b over 2a, which would be...
Wait, hold on. You're absolutely right, but what do we call that?
X.
X equals, yeah, negative b over 2a. But what are we finding here?
The axis of symmetry.
Thank you. Okay, this is for the axis of symmetry. You need that in order to find the vertex. Very good. Keep going. Sorry.
So it would be negative 3 over 4, but you do keep change flipped, so it'd be... And then first you do 2 times 1 over 4, which would be 2 over 4, which is 1/2.
Okay.
Okay, so you keep change flipped, so it'd be negative 3 over 4 times 2 over 1.
Love it.
Okay, and then it'd equal negative 6 over 4, which would simplify to negative 3 over 2.
Beautiful.
And then that's your axis of symmetry. X equals negative 3 over 2.
Mm-hmm.
And then you plug it in, and first you square it. So it'd be negative, yeah, plug it in. And then you square it, negative 3 over 2 squared.
Okay. So we've got 1 over 4. What is negative 3 over 2 squared?
9 over 4.
Uh-huh.
And then you multiply by 1/4.
Okay.
And then you get negative 9 over 16.
Keep going.
You get negative 9 over 16. And then you do 3 over 4 times negative 3 over 2. Which would give you negative 9 over 8.
Okay. Hold on. Wait, did you say negative 9 over 16?
Wait, I think hold on.
It should be positive, right? Because when we squared it, we got rid of the negative. But you're right. Yeah, up until this point. And then what? We're missing one more thing.
Oh yeah, no, and then you do 9 over negative. Well, I got the same answer, but I did negative 9 over 16. Wait, I feel like I'm doing something wrong here.
Everything is right other than that negative in front of the 9 over 16.
Okay.
It should be a positive 9 over 16. But you're also missing one extra term.
The plus 1.
The plus 1. There we go.
But then you do 9 over 16 minus... Oh yeah, no, it was positive. So it's 9 over 16 minus 9 over 8. So you have to multiply by 2
Okay.
on the right side. So it'd be 18 over 16.
Mm-hmm.
And then it'd be negative 9 over 16. Okay, that's where I got the negative 9 over 16.
Okay, so you got negative 9 over 16
And then you add
plus
1.
1.
And then it'd be 1 over 1. You multiply by 16. So
Yep.
it'd be 16 over 16. And then negative 9 plus 16 would be 7.
Good. 1 is the same as 16 over 16, so you get 7 over 16. Very good. That was excellent. Let's give a round of applause for Daniel. Say that one more time.
There was no negative before the A term.
Very good. Our A term was positive, and if our A term is positive, our graph looks like this, and this graph has a minimum. Okay? Yes, Sophia? Mm-hmm. Okay. Before we talk about that new form, we do have to talk about even versus odd functions. This is the easy part, okay? So an even function is when you plug in negative x for x, it'll spit out the exact same y value. So it doesn't matter whether your x value is positive or negative, okay? Your y value will be the same. This is very important because it's very similar to a quadratic. If you plug in 3 for x squared, you'll get 9, right? If you plug in 3 for x, 3 squared is 9. What else will give you 9? If you plug in what else for x, if it's f of x equals x squared? Negative 3 will also give you 9, okay? That's an example of an even function, okay? An odd function occurs when you plug in x or negative x, you're going to change the sign of the entire function, okay? That's what we call an odd function. So, how we do these problems, we're going to look at the most basic form. We're just going to determine whether it's even, whether it's odd, or whether it's neither. We're not going to talk about the graphs. We're not going to talk about the symmetry, okay? I just want you guys to be able to identify even, odd, or neither, okay? So, for the first one, for all of these examples, the very first thing that we're going to do is rewrite the negative of the function. So, what would negative f of x be? If f of x is 2x, if you made the entire function negative, what would our new function be?
Negative 2x.
Negative 2x, okay? You just stick a negative in front of the function, okay? Now, what we do second is we plug in negative x wherever we had an x, okay? So we're going to write f of, and instead of x, now we're putting negative x, okay? If when we plug in a negative x, we get the original function, it's even. If we get the negative function, then it's odd, okay? So when you plug in negative x, do you guys agree? I rewrite it as 2, and instead of x, I'm putting negative x. I can rewrite it like that because I'm plugging in negative x for x. What is 2 times negative x? It's negative 2x. Now, take that and compare it to both your original functions. Is it the same as f of x or negative f of x? It's the same as negative f of x, right? So when f of negative x is the same as negative f of x, we call this an odd function, okay? We call this an odd function. So if you change the value of your x, if you change the sign, if you make it negative, and it makes your entire function negative, we call that odd, okay? If you change the x value to negative and it stays the same, then we would call that even. Okay? Let's do another one. So in B, we've got g of x equals x squared minus 2. Before you plug in negative x, rewrite negative g of x. What would negative g of x be?
Negative x squared plus 2.
Good. Negative x squared plus 2. Change the sign of every term of your function. So do you guys see how the x squared was positive? We changed it to negative, and then minus 2 became plus 2. Yes? Questions on that? Okay, so we changed it to negative. Now we take our g of x, and what do we plug in for x? Plug in negative x. Yeah, so it's going to be negative x squared minus 2. You guys with me? No?
It's gonna be even.
Why?
Because if you negative x squared is positive x, and so the x minus 2, which isn't equal to negative g of x. So when g of negative x isn't equal to negative g of x, that means it's even.
Okay, I like where your head's at, okay? Write a little side note for yourself, okay? This little side note, okay? If you square negative x, do you agree that this is the same as negative x times negative x? What's a negative times a negative? So this is the same as x times x, right? And how could we rewrite x times x? X squared, right? So check it out. If this is going to change to x squared minus 2, we're okay with writing it like that? Does it match the original function or the negative function? The original. So when you change the value of x, when you change the sign of x and you get g of negative x equals the original function, this is what we call an even function. Okay? This is what we call an even function. We're going to see more examples. So if you didn't get it right now, just wait until we go over the next 4. Okay? What's that? No, we're going to do it together. Okay. C. H of x equals 2x squared plus 2 minus, or plus x minus 2. Guys, what do I do first? Brandon? Good. Negative h of x, because this is good for us comparing, right? What would negative h of x be? Adam?
Well, that would be negative 2x2 minus x. Would it be plus 2?
It would be plus 2, okay? Change the sign of everything. All right, now we have h of x, we have negative h of x. What do I do next? Daniel.
You do h of negative x,
Very good. What do you get?
negative 2x squared minus x minus 2. So,
I disagree.
wait, okay, I did something wrong then.
Cody?
You put we have negative 2, you put the x in, negative x in parentheses.
Very good. Okay, so change this, guys. Make this a negative x squared in parentheses, right? And then what happens when you square negative x, Cody?
You get a positive, which is x.
Good. So h of negative x is going to give me a positive 2x squared minus x minus 2. Now, does it match the original one?
No,
Does it match the negative function?
no,
So is it even or odd?
neither.
This one is neither. Because it does not match either of the original. Yes, Isa.
When you plug in the negative x, do you plug it into the original equation or to the negative?
Into the original equation. That's a really good question. So plug it into this equation, okay? And now, technically, guys, if you want to write this, there are parentheses around this negative x and there's a plus sign here, okay? But adding a negative value is just the same as subtracting it, okay? Daniel?
I didn't put the parentheses, and I just got negative 2x. The thing I said, and I got neither as well. Does it work, or do I have to put the parentheses?
No, you have to put the parentheses, okay? Because if you wrote that negative 2x squared, that might work for a different problem, right? And then you would be, you would get it wrong if you put that it was odd or even, okay? Good questions. Any other questions? Yeah, Isa?
Wait, why is it 2x squared? Wouldn't it just be x,
Where?
like on the second one?
No, but there's a 2 in front of it, right? So negative x times negative x will give me...
I'm saying, like, wouldn't it just be x without it being squared?
No,
Why?
because it's negative x times negative x. Right?
Okay, yeah, but
Which will give you a positive x times positive x. This is not the same as just 1x. Has to be x squared because it's x times x.
okay.
I feel like I didn't answer your question.
No, I get it. Whenever it's like a negative x, it always turns into x squared because it like equals
Mm-hmm.
2.
Yep, because there's always going to be 2 of them, okay? All right, let's do another one. D. What do I do? Good, negative f of x, right?
Yeah.
If you change it to negative, would be negative 5x. Perfect. Then what do I do after I write negative f of x?
5 of negative x equals 5, then in parentheses negative x.
Mm-hmm. What do I get there, Adam?
You get negative 5x.
Good, negative 5x. Does that match the original or the negative function? Negative one. So is it even, odd, or neither? This one's odd. Because f of negative x was equal to negative f of x. Okay, so if changing the sign of your x value makes your entire function negative, it's odd. If changing the sign of your x value doesn't change your function, it's even. Okay, and then another way that they can word it, just to help you guys out, and I wrote it down below, go ahead and highlight the portion of those notes that's in quotation. So a function is even when you evaluate the function at x and at negative x, and the y values are the same. And a function is odd when you evaluate the function at x and negative x, and the values are opposites. And then we have 2 more examples, and then we move on. Okay. Next one is E. What would we do here? L?
Negative g of x equals negative 2
Mm-hmm. So negative g of x is equal to negative 2 raised to the x power. Okay. Then what do I do? Isa?
Then plug in negative x, so g of negative x
Equals?
equals 2 to negative x.
Excellent. We're raising it to the negative x power.
Which gives you 2x, well, like 2 raised to x.
Does it? How would a negative exponent change my result? Ronnie?
Into a fraction.
Good. So what would my fraction be?
1 over 2.
1 over 2 to the x power. Remember, a negative exponent means you flip it over your fraction, right? Because this is 2 to the negative x over 1. So flip it, make your exponent positive. Does this match either of my originals? So what is it? It's neither, even nor odd. Yeah, Daniel?
Unless it starts out as a fraction, is anything with the exponent as x going to be neither?
Yes. Mm-hmm. So any exponential function will be neither. That's a good point. Yep. But your variable has to be the exponent. Does that make sense? Like x squared could be even or odd,
Oh yeah.
right? But if it's
like if it was x as the exponent.
correct, if your variable is the exponent, good. Okay, F. What do we do? L. Good. Just change the sign of both. After we find that, what do we do? Isa?
You plug in negative x, so h of negative x equals 2 times negative x squared plus 3.
Good.
And then that gives you 2x squared plus 3.
Does it match either one?
The original.
It does match the original.
So would it be even?
It would be even. Do you guys see that? So since it matches the original, since h of negative x is the same as h of x, we consider this an even function. I see some confused faces. Guys, ask me questions.
Wait, so
Yes.
so if I was to match the negative, it would be like negative h of x.
Correct. It would have to match the negative h of x. So that's why we're writing both of them up at the top, right? If it matches this one, it's even. If it matches this one, it's odd. What happens if it doesn't match either one? It's neither even nor odd. Okay? Nasia, you good? Okay. Gabby, you good? Okay. Gabby, are you good? All right. Any other questions, guys? This is the first time we're seeing this, okay? So ask. We're Gucci? All right. So the next thing that we're going to talk about is something called vertex form, okay? So we've seen quadratics in what we call standard form. And let's just write it out again. Do you guys remember what standard form was? Oh boy. And Brandon?
Highest exponent to lowest exponent.
Good. Highest exponent to lowest exponent. So for a quadratic, it would be f of x equals... Bryson, do you remember it? No? Daniel?
Ax plus b minus c.
Oh,
Close.
Wait,
ax squared.
Ax squared plus b x
Plus c.
plus c. Okay, so this was standard form. Okay? Now, write this one down. The next one that we're learning about is called vertex form. Okay? And watch, it's f of x equals a times x minus h squared plus k. Bryson?
After I copy this, I'm trying to go to the
Yes. Brandon?
and I go to the
Yes. Why do you think it's called vertex form?
Because it finds the vertex.
It does find the vertex for you, okay? So our vertex in this form is whatever the h value is, comma, the k value. Correct. So the k is going to be the vertical shift, and the h will be the horizontal shift, right? So whatever you're shifting horizontally, that's going to be your new x value vertex. And whatever you're shifting your k value or your vertical component, that's going to be your y value of your vertex, okay? So we're going to use h and k to figure out our vertex. All right, so let's check it out, okay? For our first one, okay, all we're going to identify is what is our a value, what is our h value, and what is our k value. And that tells us everything we need to know about this function, okay? So, in this first scenario, what is the a value? It's 1/2, okay? So it's 1 over 2. What is the h value? Be careful here. Brandon? Remember, it's x minus h. So h would be what? The 4. But it's a positive 4. Correct. Okay? Because what world are we in when we're inside the parentheses? Opposite world. Okay? So h is 4. What is k here, guys?
0.
It's 0. Because technically there's a plus 0 here, right? So your vertex, right, is h comma k. In this example, what's my vertex? 4 comma 0. Do you see how easy that was? Okay. So vertex form is super helpful in finding the vertex. Okay. So our vertex is going to be at 4 comma 0. Could anyone tell me where's my axis of symmetry going to be? Adam?
X equals 4.
Excellent. X equals 4. How'd you get that?
Because that's the h value.
Yeah, it's the h value of your vertex, okay? Now, look at the a value. And someone tell me, is this going to be a shrink or a stretch? Gabby J? It's a shrink. Why? Excellent. It's a shrink by 1/2 because 1/2 is less than 1. Now, there was a translation. We went 4 units to the right because, do you agree, this minus 4 is an opposite world? And since it's inside parentheses, it's horizontal. And we would move 4 units to the right. Do you guys remember that? Okay. And then, is there a reflection here?
Yes. Yes.
No.
Who says no, raise your hands. Who says yes, raise your hands. Someone who said no, explain to me why there's no reflection. Bruno? There's no negative in front of the A, okay? So we're going to put none. Remember, the only reflection that can happen is if this A term was a negative. And since it's positive, we're going to have a right side up graph.
How did you get x equals 4?
Just the H value. So X equals your H value.
Okay.
Okay? All right. So let's go ahead and graph it. My vertex is at 4 comma 0. So go 4, 0, put a dot. And then my axis of symmetry is going to be a vertical line through that point. Are we all okay with that point being of the vertex? Yes? Now, if I shrink a parabola by 1/2 vertically, is it going to be skinnier or wider? Ronnie?
Wider.
It's going to be wider, right? Imagine flattening your graph and making it like wider, right? Like smushing it in a machine that like shrinks it vertically, right? So we should get a wider graph and it should be facing up. Now, for these types of questions, we're no longer using the table, right? So your graphs don't need to be perfect. So make sure if your graph is going to be wider, this one needs to be wide, more bowl-shaped. Make sure you exaggerate it, okay? Make sure you exaggerate the fact that it needs to be wider. Yeah, Alexandra.
So finally, like the translation where we do like 0 and then we do 4 units to the right.
Correct. So since K was 0, did we shift it vertically at all? Did it move up or down at all? No, the only change that happened was a horizontal one. It moved 4 units to the right. Do you guys see that? And that's because our k value was 0 and our h value was 4. How is the h value 0? The h value was not 0.
Oh, I meant.
The h value is 4. Since there's nothing after, right? There was no k value. There was nothing added. Then it's 0. Okay? Good questions. Any other questions, guys? Let's do another one, okay? Let's do B. All right, let's identify. What's A? L? A is 2. What's B? Oh, there's no B. Excuse me. What's H? -5. What's K, Bruno? K is 0. Where's my vertex going to be? Cody?
Is it -5, 0?
It's -5, 0. What's my axis of symmetry going to be? Not -5. We never say our axis of symmetry is a number. Thank you. X equals -5. You guys are still putting that. You're saying AOS equals -5. That's no bueno. Our axis of symmetry is a line, so it has to be X equals. Are we okay with that? Because we're still losing points, okay? All right, so at -5, 0, I'm putting a point. My axis of symmetry is going to go down like this. All right, now, what is my A value doing to my graph? Gabby? Excellent. It's going to be a vertical stretch by 2. And a vertical stretch by 2 is going to make it skinny or fat? Skinny. Imagine, right, if you grabbed your head and your toes and a machine pulled you apart vertically, would you get skinny or would you get fat? You would get pretty skinny, right? If that machine was pulling you apart, like stretching you out like spaghetti, okay? Make sure you understand the difference between vertically stretching and vertically shrinking. Cool? So we should draw a skinny graph. It went on keto. Do you guys see how this one's skinnier than the last one? Okay. I had one more question for you guys. Why is it facing up and not down? Alexandra? There's no reflection. What would cause a reflection? Bryson?
Negative.
A negative, okay? There was no negative in front of our A value. Cody, you good? Okay. What is the A value here?
1.
No.
Negative.
It's -1, okay? What is the H value here? 2. And what is the K value? 0. So, where is my vertex? 2, 0. Where's my axis of symmetry? Thank you. X equals 2. So, I'm going to go 2 units to the right, 0 units up. Here's my vertex. My axis of symmetry is going to just be the vertical line through that point. And now let's look at what the change in the graph is based on the A value. What is an A value of -1 doing to my graph? It is a reflection. Over which axis? The x-axis, okay? So I'm a visual person, as you guys know, so I always just draw a little reminder, okay, my graph should be facing down. If it's not facing down by the end, I know I did something wrong. Is it skinnier or flatter? Or is it the same? It's the same. Why is it the same, guys? It's 1. Do you guys see that? If that number is 1, -1 or +1, there's no stretch or shrink in your graph, okay? So it's just going to be a regular parabola, but it's facing down. It's not skinnier, it's not fatter. Yes. Mm-hmm. Wait, did Brandon go?
Yeah.
Okay. All right. The last examples we're going to see, all of my K values for the previous examples were what? 0. So we only moved horizontally. Now we're also going to move vertically, and you just have to add the k component, okay? It's not hard at all. So let's move on. All right, for this next one, what is my a value? -2. What's my h value? -2. What's my k value? 3. So my vertex is going to be at -2, 3. My axis of symmetry. Thank you. Let's go ahead and plot it. -2, 3. Axis of symmetry down that point. Now we have to look. What value is going to tell us about the graph, if it's skinny or fat? A. What is an a value of -2 going to do to our graph? It's going to be a reflection over the x-axis, but there's something else that's going to happen. Daniel?
Stretch by 2.
Good. It's a vertical stretch. Good. By 2. Remember, even though -2 is less than 1, I agree with that. You're looking at the absolute value. So the absolute value of -2 would be +2, right? And that number is bigger than 1. So we are still stretching it. I treat the negative as a separate transformation than the 2. If we're stretching something by 2, if something's grabbing our head and our toes and stretching us apart, are we going to get skinny or are we going to get fat? Skinny, okay? This one's going to be skinny. And a reflection over the x-axis means we're facing down. So from that vertex, draw a skinny downward graph. Gucci? Bruno?
How do you know, like,
If it's skinny or whether it's flat?
yeah, you should know where what points to put it on.
Oh, so we're not worried about the points, okay? Since we're no longer using a table, I just want you to be dramatic. So if it's supposed to be skinnier, make it a lot skinnier. If it's supposed to be wider, make it a lot wider, okay? Does that make sense? I'm not going to be super particular about what points it goes through, right? Because we're just sketching it. I just want your vertex to be spot on, and I want your skinny versus fat to be appropriate. Make sense? All right, good question. Let's do another one. B, g of x equals 3 times x minus 1 squared plus 6. What do I do? L? Good. Where's my vertex? 1, 6. Where's my axis of symmetry? Brandon? X equals 1. Okay? So let's put that on our graph. 1, 6. And an axis of symmetry of 1. Okay, guys. What will A equal 3? What kind of transformation will that cause? Gabby? Good. Now, visualize a machine that's grabbing your hair and your toenails. And I know, it's very graphic, okay? And pulling you apart vertically, right? Will you get skinny or fat? Skinny, okay? So, you're going to get really skinny, and are we facing up or down? Why? There's no negative. A was still positive. Are we Gucci with that? I'm serious, guys. Like, envision Saw, the movie. Like, some creepy, disgusting machine that is pulling you apart vertically, okay? You're going to get super skinny. Or imagine it crushing you, and you're going to get fat. Okay? Whatever you need to do, visualize. Okay, last one. L.
A equals 1/2.
Mm-hmm.
H equals -4, and K equals -2.
Excelente. What is my vertex? Someone new. Isa.
-4, -2.
Excellent. What's my axis of symmetry? X equals -4. So on my graph, go to -4, comma, -2. That's down here. Draw my axis of symmetry. And then what does my A value tell me about my graph? Cody?
The graph's gonna be fatter
It is going to be fatter. Why?
because it's less than 1.
It is less than 1. So it's a vertical shrink by a half. So that said machine is now pushing us together, making us nice and plump, and we're facing up. So make sure you just draw a wide graph. Gucci, let's go.